So today we're going to be going over piecewise functions. So a piecewise function is simply a function that is defined by many other functions, and the function that changes its I would say its function with different values of x. So maybe you're going to have, okay, let's say your graph is like this, eh? Then you have got your function. It's coming. Let's say this is 2, this is 2, oh, this is 0. So this function is coming. It comes, and then when it goes at 2, well, the function changes and it starts going like this. Maybe it goes to a certain value, let's say 3. At x is equal to 3, the function drops like that. So now these functions are defined by something like, you find maybe your g of x is equal to you're going to have something like x is equal to maybe x minus 2. G of x is x minus 2, maybe when x is greater than 0. Then maybe x is let's say x, I can put anything here, maybe x squared when x is less than, when x is less than or equal to 2 maybe. So now how do we graph these? Well, we can graph these, how we evaluate and graph these is what I'll be talking about in this video. So let's say we're going to have a function. It can be arbitrary, by the way. Maybe g of x being equal to x, let's say x plus 4 when x is greater than 0, and then let's say they can even go to 3, by the way. So let's try to make them 3. Then g of x is equal to x when x is greater than or equal to 0, and then let's say we have it's x squared when x is greater than 2. So now how questions come, you're going to be told to say find g, here we can put the range, maybe greater than or equal to 0, but then x is also here it's less than 0, here is greater than 0, and you can forget the range. And then for we can still leave it, you still get the same values either way. I just want you to make them 3, so at least you have a lot of exposure. So let's say find g of 2. Well, you're going to look at your equation, and then you're going to say at which values of x is g of x, is x greater than 2. So when you look at this one, here x is greater than 0, so x can be equal to 2 in this case. So this function is valid for this kind of x. But then when you look at this one, it's saying it's less than or equal to 0, so meaning that x cannot be this one because it's greater than. So now g of 2 is we are going to get this function, and where there is 2, where there is x, we're going to put 2 plus 4. So g of 2 is simply equal to 6, just like that. And then when you have something like and then for this g of 2, you can be tempted to use this one, but then this one is strictly saying is greater than 2. So this one is greater than or equal to 2. And then when you have things like find g of negative 2, this one is not valid because here x is greater than negative 2. So we can go to this function, this one here, where your x is less than. So I'm going to say g of x, where there is x, you're going to put negative 2, so it's going to be negative 2. And that's, we've evaluated. This is how simple piecewise functions are. The problem sometimes comes when graphing. So I'll give an example of this one, how you'd actually graph this one. So then we can try to graph this piecewise function. So you can use your table of values, I think. So you can use the first one. So you can say x, y. So this is the first one. For the first function, I think two are enough. Two or three values. So I'm going to put 0, 0, -1, then we have what? 1. When x is -1, this function, we are starting with this one by the way. When x is -1, g of x, which is equal to y, will be 3. Then when x is 0, g of x will be 4. When x is 1, g of x will be 5. Then for the second one, you have got your x, you have got your y. You can choose 3 values as well. And then for this one, you can try to choose where. So for this one, when x is 0, when x is 0, y is also 0. When x is 1, y is 1. When x is 2, y is. When x is 1, y is 1. When x is 2, y is 2. Because x is equal to y. Then for the third one, you have got your 0. Then you have got your -1. Then you have got your 1. So here when x is -1, y will be equal to 1. When x is 0, y will be 0. When x is 1, y will be 1. So this graph is actually coming something like this. You can try for all values. When x is negative, y is always positive because there's a square there. So when you try to graph these now, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just a rough sketch. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So then you're going to have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative, 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 negative. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These are negative. So you can graph this one. The first one is we have -1, 3. So that's -1, 3. You're going to have 4, 0. That's 4, 0, 4. Sorry, so that's 0, 4. For the other one, you're going to have 1, 5. So equation is actually coming something like this. But then remember, this equation is only valid for x is greater than 0. So this equation starts here, then it goes this side. And then for this one, since it's just greater than, it's not or equal to, you can put an open circle there. If it was greater than, you could have shaded the circle. So then you look at other functions. We look at this one, the second one, which is when this one is for x is greater than 0, greater than or equal to 0. So this one's starting at 1. When this one is 1, this one is 1. When it's 2, this one's 2. When it's 3, just like that. You've seen how this one is going. When it's 0, it's 0. So it's starting from here. It's going it's for values of x that are actually less than 0. So this one is actually going down. So the values of x are always less than 0. So now it can go this side, and then here we'll have an a closed one because it's greater than or equal to. And then for this one now, you have got your -1, 1, -1, 1, 0, 0, 1, 1 as well. So this function is actually coming something like this. But then we're being told it's for values that are greater than 2. So now so values that are greater than 2. So now how this function goes is when x is negative, y will be positive but the square. So when x is 2, this one will be 4 positive, like this. Let's say if we had another function here that was 2, let's say -2, x would be 4 because y is x squared, 4 positive. It would be somewhere at 2, 4. So when you look at how this one's going, this one's actually going like this. But then this one is for the values of x that are greater than 2. So values of x starting at 2 going this side. So we can go at 2. So now for values of x that are greater than 2, we can start maybe at 3. When x is 3, y is 9. Let's do something that's in range. Okay, when x is 2, this one is 4. And then it's a quadratic function, so it goes something like this. And then we're going to put our opening there. So that's how you graph this. You can try many other practice problems that I'm going to do in the videos to come.